Where are we? There we are.
Hello and welcome to Metra Tech Tips. Obviously, Adam's back, but apparently he's forgotten how to be a production manager.
I have been out for way too long, is what it's come down to. But I'm back, and so we are now at the point where I can relearn it.
Yeah, and actually, today's kind of fun for multiple reasons. First off, for those of you who haven't noticed, we look slightly larger than usual.
It's been a little while since we've been...
Adam has the lighting set up for today's demonstration on the panel, which means no overhead lighting.
Yep.
Which makes us both look post-turkey in a pre-turkey environment.
Sure. Whatever that... Sure. Well, and we have some fun things happening today.
Oh, and it is worth looking like this for what you have going on.
Yes. And
so,
yeah.
Fortunately, or unfortunately for you guys, fortunately for me, I will not be in this show because this is really Adam's baby. He put this whole thing together and he's very excited about it.
Yep.
So I'm going to step away and Adam's special guest will step in because of our, spacing and COVID stuff.
Yep.
So if you'll start the usual routine of housekeeping, I will step out, pass off the mic, and it's all about you, baby.
Perfect. So everybody, as always, thank you for checking in with us today. If you have any questions about whatever it is that we are talking about, feel free to leave those over in the chat section over here on the side. Or if you're watching this after the fact, feel free to leave it down in the comment section below. Like Brent was saying, you'll notice that the lighting looks a little bit different. We have a very special reason for that, so that we can actually see some really cool stuff that we brought in for today. But today's episode, well, before I get to that, like, share, subscribe, hit that little bell notification to let you know whenever we do go live. All of those things really help us out. It lets us know that we've got good content for you. And if you do leave a comment down in the comment section below, if you're watching this after the fact, we do monitor that and we do respond to those questions or comments or anything else that you have for us, so that we can keep you involved with that. So, but without further ado, we have Mr. Joe Padula with us today. Joe, welcome back to the show.
Thank you.
We really appreciate you for doing this. For anybody who's has not seen the previous episode that you were on, you are an instructor for Installer Institute, correct?
Yes.
Perfect. Okay. So, Joe...
What is Installer Institute?
Well, Installer Institute, that's Brent off camera again. That's Installer Institute is a fully accredited?
Fully accredited.
Yep, fully accredited institute where you can actually learn installation requirements and techniques. Actually, you probably have a better explanation for what it is.
So it's well, we're celebrating our 30th year to start with, which is a big deal for us. We train both in the 12-volt realm and in the 110-volt home audio realm for new technicians coming into the market or technicians looking to increase their skill sets. We've got a wide gamut of content, ranging from basic electronics to car audio installation to security and remote start to structured wiring and home automation and a bunch of stuff. So if you have any interest, going to installerinstitute.edu is our website, and there is a
How long is the course?
Oh. Multiple courses. We have continuing education courses that are as short as 40 hours and full programs that are 900 hours, and there's things in between as well. So,
yeah. So if you want more information, go on to installerinstitute.edu.
Yes.
You can find out more information for that and see if it's something that you want to get into yourself. I can definitely say that if you are trying to get into car audio installation of any kind, whether it be just car audio or just 12-volt installation or accessories, it is definitely worth it. Before working here, I actually worked with one of the graduates actually two of the graduates from Installer Institute. So they are definitely worth it to look into if you are trying to break into that type of work. They also, like Joe was saying, they do a course on home installation as well. So that is definitely worth it, especially for us on our side. But we are, of course, very grateful that you were able to come in, and as I understand, on your vacation time as well. So we really appreciate that.
No problem.
But today, we're really excited because we are talking about volt-ohm meters.
Yes.
Now, this is something that most everyone has used a volt-ohm meter, and I would even say they are using them on almost every job. And in fact, they should be using it on every single job just to verify and confirm that things are working correctly.
Should there be one in every truck?
There should be one in every truck, which actually is another topic for us to talk about later on. But it's one of those items where we may learn, okay, here's how you switch it to this setting and it beeps whenever you have a closed circuit, right? That's great. That tells us, that's just one function. And if that's one of the only functions that's a really valuable function. Sure. But there's so much that these do.
Yeah.
And so we really wanted to have an episode where we talk to somebody who is knowledgeable about how to actually use these things. So, Joe, without further ado, let's talk about
Absolutely.
Multimeters.
So, I brought with me a variety of different meters here, and one of the first things you're going to have to think about if you're using one of these or getting ready to purchase one is, which one do I get? And, if you start shopping these, you can find them Harbor Freight specials, 10, 20 bucks, all the way up to multiple thousands of dollars for meters. And, one of the questions would be, what's the difference? Why? So, here I have two of the more entry-level meters.
Switch over to that.
And these are by the same, they're labeled differently, but by the same manufacturer ultimately. But one's a little bit lower end, one's a little bit higher end. And one of the things you'll find on entry-level meters that you don't get on more advanced ones is they are not auto-ranging. So the range of a meter is going to determine how high or low a voltage or resistance it can measure. So if you look at the dial on this one here, I don't know if you guys can see or not, but there's a lot more settings. Just in voltage alone, we've got 2 volts, 20 volts, 200 volts, 1,000 volts. And what this means is that I need to kind of know what voltage I'm measuring before I measure it, which is a little bit of a conundrum there. How do I know what it is if I haven't measured it yet?
Right.
So there could be certain expectations. If I'm measuring in a car and measuring a 12 volt battery in a car, well, the 20 volt range should be enough for that. But if I'm measuring a smaller voltage, I may not know. So a way to get around that is a little bit better meter that has auto ranging. So on this one, it has a setting for voltage, and that's all I get is volts. And whatever voltage I connect to this, it will automatically set to display the range to the meter's capabilities.
So those, when you're dealing with these setups, then it basically what you're finding is that, and the numbers, when you go to select the different voltages on this, I'm actually going to bring this here closer to the camera a little bit. So if you all can see right here on this, and if your voltometer has these, that's what you're looking for. If it doesn't have those, it may actually be an auto scaling one, or an auto range setup on it. But basically what you're talking about then is that you want to find out where you need that decimal point so you can actually get an accurate reading, correct?
So, if I grab something that has some voltage on it, get a little battery here or something. So I brought myself a little drill battery.
These are great, by the way. A little handy tip for you guys that are out there doing installations: if you are running into something where you just need to find out if you have voltage going across something, or if you need to pop a speaker or something like that, take the battery from your drill.
Preferably not the 24 volt.
Preferably not the 24 volt, but usually they have like an 18 volt or a 12 volt breakout on it, and you can just put wires to that. Test it on something that you're not worried about breaking first before you do it, but then you can use that to actually pop speakers. You just hit it and put the lead to the speaker and release it right away, and that'll actually pop the speakers if for some reason your generator is missing or something. So.
And that's a real old school way of doing that. In today's world, we try to talk to technicians and maybe not doing that.
Yeah.
Because like Brent said, there are 18, 24 volt batteries out for drills, and if a guy puts a 24 volt battery on a tweeter, that could be instantaneous destruction.
Yeah.
There are tone generators and devices that are designed to do that are safer. In the automotive world, if we start probing wires with a 12 volt battery, you think you got a speaker wire, you may have an airbag wire, and there's reasons not to do that. But done it for many years.
Yeah.
If you are going to do it, a 9 volt transistor or a 1.5 volt dry cell, a little safer than something a high current drill battery, because these can put many amps out where those others cannot.
Yeah.
But the right tool for the right job is really where we should be.
It's a good reason. I guess that's a good reason we have you on the show today.
Not to say I haven't done it in a pinch, but not recommended to this level. All right, so right now I've got this supposedly 12-volt drill battery tied into my meter. And I'm on the volts DC setting, and we should probably talk a little bit about that, but DC is what batteries create, and it's a voltage that does not change over time. And I set my meter to the 200 little m range. So this is, again, where ranging becomes a little bit important to understand what you're looking at. Is this the right orientation?
Yep.
Yeah, okay. So I printed out this little chart, and in electricity and metric system and everything else, there are prefixes to our measurements that kind of tell us what we're doing. So the little m that this meter is set to right now on its setting represents millivolts, and millivolts are 1/1000th of a volt. So at this scale, they can read up to 200 thousandths of a volt, and that's its maximum. Well, we're reading a 12-volt battery right now. So obviously this is 12 volts, that would be 12,000 millivolts, and this only reads up to 200. So at this point in time, my meter, and I guess you can see the display here or not.
Flip it back.
Yeah, there we go.
That way.
Yeah, our display is reading OL. OL, anytime your meter reads that, it means out of limits, beyond what the meter can resolve and show. So that is the wrong range for this meter. If this was an older analog meter, one with a needle, I probably would have just damaged the meter, because the needle would have swung like, would have tried to spin around 10 times and bent the needle or broke the mechanism inside. On this, it doesn't really do anything, but it doesn't give me a reading. I can switch it to the 2-volt range, and same thing, I am not going to get a reading. I can switch it to the 20-volt range. Okay, now I get a reading, and I can see that this supposed 12-volt battery is actually reading 12.17 volts. I can switch it to the 200-volt range, and it still reads 12, but I've lost a decimal. I don't get, it rounds up to that last 0.2. And if I switch it to the 1000-volt range, I don't get any decimals at all, I just get 12. So this has to do with accuracy in the meter. Usually what's recommended is we start with the highest range and then work our way down to get the full display of the meter. So all 4 digits are showing, and that gives us the best accuracy. In an auto ranging meter, that is not necessary. I can just plug into, make sure I plug into the right places here, it makes a difference. And I can just plug into volts DC, and so you got to plug in the right place. Common, volts, that should be displaying. Why is that not displaying? And so for some reason I just grabbed this out of a bin. This one's not displaying on volts. But normally that would show me the proper voltage, and it would display without having to do the ranging thing. So this is actually a defective meter. But that's the easy part of it. If I go to my little bit higher quality meter here, same thing, this is auto ranging, and it will jump automatically to my range. I don't have to set the different
right to what we're looking for.
Right.
Okay, so you've got then again, it just basically just makes it easier to track what that is.
Yeah,
so,
it does the thinking for me and shows me where I'm at, so I don't have to change anything.
Which is really helpful when you're on the job. When you're actually there, it's like, okay, you can pick this one up and you can do that, but that's that one extra fraction of a second that you're having to put thought into putting it into the right setting. That doing it this way, it takes that load off. Yeah, and it also leads to higher accuracy, because your meter is going to give you the maximum resolution of what it can do in the display. Gotcha. It is important though, when you have an auto ranging meter, on this one I've selected the range that I'm going to be at. I know that I'm measuring 20 volts. This one could just as easily say 12.2 MV over here in its little display, meaning small MV, millivolts. So it could read 12.2, and in my head I would go, oh, 12.2 volts. But if I miss that little tiny m, then I've made an error by a factor of 1,000, because I'm not getting the... So you're actually reading, if that was the case, you're actually reading a much smaller, 12 millivolts instead of reading 12 volts. So, if I were to just plug something in here and maybe touch this or something, right now, well, that's actually even reading less, but it could read fractions of a volt down into the thousandths of a volt, and I would have to see that M in order to know that that was happening. So that's an important factor. That's really interesting. So that's so one thing to be aware of then when you're using an auto meter. So the nice thing again, it's kind of give and take. If you are using one of these where you're deciding what range
Correct.
you need to be in, you know what you're reading is in that range.
Right.
Versus something like this where if you don't notice that it's saying that it's in the millivolts or in the regular volt range, you can get the wrong reading for yourself.
Yeah, and those milli and the different levels here. There's milli for 1,000th. There's kilo for times 1,000. There's mega times 1,000,000. That will change in that little register over there for the different things that the meter sees, and they carry through all the functions of the meter, whether we're doing resistance or voltage or current. It's all the same. So you got to watch it all the time when you're making measurements to make sure you understand what you're measuring.
So luckily, most of what we're dealing with, either in the 12-volt car side of things or in the home theater or in the small commercial application, very rarely are we going to get into even the kilo.
Hopefully not. Yeah.
Hopefully we shouldn't be anywhere near that.
Yeah.
I mean, that for something like that, we're talking like
in
the big
voltages,
transfer stations.
Or actually, transfer stations goes over into the millions of volts.
Wow.
But in voltages, we're probably in the single digits for most anything we do. Although there may be some really tiny voltages if you're trying to measure a signal out of a preamp or something like that, that may be down in the thousandths of a volt.
Yeah.
And those maybe in the millivolt range. But when you get into the other readings, like your capacitance and resistance, those could easily be anywhere from micro, which is 1,000,000th, all the way up to mega, which is times 1,000,000. So we kind of live in this micro to mega range with electronics, and it's important that this is downloaded from the internet. If you don't understand what these are, it's easily found, but it's important to understand what those mean so that you know what the meter's telling you, because it's widely differing depending on what you see.
So it really seems like one of the important things to know is this symbol that they're working with.
Yes, absolutely.
So if you are in that millivolts range on the meter itself, you can know that you're in that position so that you're reading it correctly for yourself. And of course, that's, again, if you're using the auto scaling meters.
And it's even more confusing because they use M twice. There's a capital M means times 1,000,000, and small m means divide by 1,000. So the case of it is important.
That's good.
And then there's also the micro, which is little u,
Yep.
and that's 1,000,000th of, and that's often seen in capacitance and things like that.
Okay.
So auto ranging or not, that's one thing that we can look at. Another thing that you will be seeing that's different on the different meters is the actual range of how far the meter can go. So on my Fluke here, if I look at my amp scale, the amps on this one is good all the way up to a 10 amp scale. Whereas on these other lesser meters, that only goes up to 2 amps. So we're not commonly measuring current, but if you have the need to measure something as high as 10 amps in a vehicle, it might be the draw of a headlight bulb or something like that. A smaller meter would not be able to measure that because it can't get to that level. And in fact, if you measure too high a current through your meter, you'll actually damage it. So if you have a meter that doesn't work...
That's always a concern of mine whenever I'm messing with something like that, because I don't want to damage it, because obviously it's not going to work. But because we could be reading, especially on the home side, we could be reading anywhere from, like you said, like the RCA outputs, we could be reading millivolts all the way up to 100 volts for its settings.
Sure. So this meter is typical of the way they are, and they're typically 9-volt powered. So if the battery is important on these, by the way. If the battery goes dead, you will have inaccurate readings or not work at all. But almost every meter has an inline fuse inside. This one right here is a 2 amp for this 2 amp meter. These are usually slow blow fuses to give you a little bit of time, but if I am measuring current with this and I go past 2, this is going to open, and once it opens it won't function anymore, it won't work right. If the meter has multiple ranges of current, it may have more than one fuse, one larger and one smaller. But if it's not working, and that's the first thing you want to look at, is to make sure that that fuse has not been damaged.
So that's really handy for, I mean, I honestly would not have thought to do that until someone taught me about it. I know now, but when I first started using them myself, that was something where when it blew on me for the first time, I was ready to go out and buy another one. Granted, it was just a little cheap, Harbor Freight, whatever, freebie it kind of a thing. But
well, the thing is, we'll get to this in a little bit, but it's very easy to blow that fuse, because the way we use the meter for measuring voltage and the way we use the meter for measuring current are different. When we're measuring voltage, the meter is in parallel to the circuit, meaning the plus lead of the meter goes to the plus terminal, the negative leader goes to the negative lead. We're measuring current, the meter has to be in series with the circuit, which means we have to break the circuit open and insert the meter in the path. Well, if you've just been measuring current and you go, okay, I'm going to set my meter to current, and while we're here doing whatever that is, and then you say, okay, let me go back to checking voltage again. Well, when I have the meter set up for current, it essentially has zero resistance, because if it's in series with a circuit and there's any resistance in the meter, it's going to affect the current of the circuit. If I take that meter and I go put it on my battery saying, oh, geez, it's not working, let me see. Well, 0 ohms across positive and negative, that's a dead short. So that's where the fuse gets blown instantly. And it happens very commonly that people forget to change the meter and move the leads. And that's one of the reasons why in most meters, the current reading and the voltage reading are on 2 separate terminals. Because if they weren't, simply changing this while it was plugged up would be enough to pop its internal fuse or damage it.
So that's why you have the. I didn't know that actually.
Right.
So the reason they have the additional ones here is so that if you're going from reading like a voltage set up for it, and then you want to read a current, you can't just take this and flip it around. You actually have to physically remove that lead and put it in the new position.
And some of them, I think this might be the one. If I'm plugged up to voltage and I turn my meter, no, that's not the one, but some of them actually have a warning. So if I'm plugged in here and I set it to volts, it's going to start screaming at me going, hey dummy, you're about to blow the fuse because you've got this plugged up in the wrong place and you're about to make the wrong setting.
Right.
Or maybe it's over here. Yeah, it's not, whatever. Yeah. But some of them have it.
Some of them have it, yeah.
Right, to warn you. But it's it's up to you to make sure you pay attention to that.
Okay.
All right, so that's auto range versus not. Range of the meter, how high or how low it can measure, that's also another thing. We saw that this one goes to 10 amps, this only goes to 2. Voltage ranges can be different on the different meters. Some will measure into much higher voltage or lower voltage. The resistance varies, so you want to know make sure the meter is going to go for the things you're trying to measure. Amperage is usually the one that makes a big deal because everything else is within the realm of what we try to measure. All right, so the next thing you want to look for is whether or not the meter is what they call a true RMS meter.
Ooh.
Yeah. So this refers to measuring AC voltages. And an AC voltage is one that is constantly flipping its polarity back and forth, and it does not remain constant over time like a DC. So we have a voltage that can be anywhere from 0 volts at one instant to the peak voltage of whatever that AC wave is another, and constantly inverting polarity. So the meter has to know, what's the overall average of that. And they do this by something called root mean square. And you can think of it as the average. It's a little more complicated than that. If you want a really good review of RMS, Tony D'Amore on YouTube has a really good RMS tutorial about how that all happens. But suffice to say, it's mathematical, and we can think of the RMS power of a AC wave as the equivalent of its ability to heat something. So if I have a resistor sitting there and I put a 12-volt battery on it, the resistor is going to develop a certain amount of heat as it's dissipating the power of that battery. If I have a 12-volt RMS AC wave, the resistor will get just as hot as it would with a 12-volt DC wave, or a DC signal, even though the AC wave may have higher peaks in it. So it's power consumption, we can think of it that way.
Right, yeah.
A cheap meter, like this Meter Man, knows that between the peaks and the dips and overall, it's going to average out to about 71% of the voltage is the RMS of whatever the peak is. And it incorporates that formula anytime there's an AC voltage. And as long as your wave that you're measuring is a pure sine wave, like a wall current or something like that, that's good enough, it'll work. But if you have a complicated wave like music or something else, or a wave that's clipping, that function does not work correctly, that math is wrong. So I brought a tool to kind of show us this real quick. Over there, yes.
Okay. You want all that?
Yep. All right, so what I've got here, and I'll kind of move this out of the way for now. This is an inverter that is designed to take 12-volt car power and turn it into 110 volts for whatever you'd want to power in your car. I've got a 110-volt plug here. This looks very unsafe, and it normally would be. But for demonstration purposes, I put a very high resistance across this so I can touch this and there's no current, there's no shock. I'm not...
So it's actually bringing it back down to a much lower...
It's keeping the same voltage, but it's limiting the current.
Okay.
So I don't have to worry about shocking myself or anybody. All right, so I'm going to connect this up to my scope here.
So we've just gone from a under $20 meter to a under $100 meter. Now we're up to like a thousands of dollars meter.
Yeah, so an oscilloscope, I'll get there eventually, but it is a meter. It's still a multimeter. In fact, it has meter functions on it that were just like these others. But it has the ability to show, in this case we're measuring voltage, not only in its amplitude, its level, but what it does over time. So I'm going to quickly change the scale of this. So right now I'm showing, if you guys can see that, I think.
Yep.
Yeah, okay. So I'm showing the output of this inverter, which is supposed to be wall power. It doesn't look like wall power though. So I'm going to change this real quick, unplug it from my inverter. I'm going to plug it into actual wall power, which again would normally be unsafe to do this, but I know it's not going to shock me because I've got this.
You've tested it yourself, right?
Yeah,
like you did the good, tongue test.
I don't do the tongue,
no,
but I
okay.
do the fingers.
Okay, good. Okay, all right.
All right, so now we're plugged into wall power, and this is what we call a sinusoidal wave. It's a smooth curve, and this is what AC wall power looks like. It's also what music looks like if I'm playing a solid tone.
Okay.
It's not the best wave that I've ever seen coming off anything. There's something going on in this room or in the power supply where this is not quite symmetrical, so maybe a little bit of resistance in one of the leads or something like that. So that's interesting to see where the scope will show us that.
Yeah.
But it is showing us 117 volts RMS voltage on this sine wave. If I plug it back into the inverter,
I got it.
Inverter's not quite giving us the 117 we had, so it's a little low. But it's still up in there in the 106 volt range. But you can see I no longer have a sine wave. I've got this interesting curve. This is called a modified sine wave. And this is what a cheap inverter does. It's the reason why you may want to buy a better quality inverter if you're going to do something in a car that's a delicate piece of electronics, like a video game or something.
Yeah, that's some serious like plateaus that we're seeing on that.
Yeah, it's clipped.
Yeah.
And it's just easier for this machine to create this wave than an actual sine wave. So they use transistors switching on and off to do it. And it's close enough for most things. It's close enough for a charger for your laptop or a light bulb or a power drill or something. But for some delicate electronics, it's not good enough. But the main reason I brought this to you is to show you this is not a sinusoidal or a sinusoidal wave. It is a square wave of sorts. It's multi-stepped. My scope still shows me the full 110 volts or 108 volts. I'm going to disconnect that output. I'm going to connect it up into my higher quality Fluke meter here. This is a couple $100 range meter. Make sure I'm connected to the right thing. I want to be on AC voltage. Okay, and I get a similar reading to the scope. I'm getting 112 volts AC, and that's just fine.
I just want to do this right here.
All right. I think if we turn it this way.
There we go. Yep, you got it.
So 112 volts, about what the scope showed us. I'm going to take it over to the less expensive meter. This is the not true RMS meter. In the 200 volt AC range. Shows us 88 volts.
Huh.
Yeah. So on this not sine wave voltage, a meter that is not a true RMS rating is going to give me an inaccurate reading. They can be off by up to 40% on some types of waves.
So that's actually because it's not giving us a true sinusoidal wave. It's giving us that clipped wave.
The shape of the wave,
math.
this meter, yeah, the math that it's applying is applying to a sine wave, and we're not giving it a sine wave. This meter is smart enough to know the difference in the shape of the wave to give us an accurate voltage reading no matter what we're doing.
Wow.
So if I'm measuring music and it's a clipped wave, I'm going to get a lower voltage here than I would here, and that may throw off what we're trying to measure, and can't understand why we're blowing speakers. It says it's a low voltage, but it's actually much higher. In its RMS.
Interesting. So you're actually, well, a couple things. One, you're showing that, look, if you're going to be testing something like that, you need to make sure that you're putting the money into an actual tester that's going to do it correctly.
Yeah.
But then also you're showing that if you are trying to test like an output of an amplifier, where along the pathway even, because you could even run into something similar when you're clipping on the RCA outputs as well.
Absolutely.
And so if you're using a cheaper meter to read out of that RCA, you're not going to get a correct reading on it.
Correct.
And then as you move your way down the line to the speaker, everything's going to look perfectly fine. As you move your way down, you're going to be scratching your head thinking that, well, I just don't know what's happening. It's just a bad speaker.
So, and it's a pretty dramatic difference there. That's a 20-30% difference or more between the two meters. And this isn't the cheapest of the meters. This is still a decent meter. There's some really low-end ones that can just be inaccurate all around. So, anytime we buy a tool, I always say to myself, buy the best thing you can, because there's going to come a day if you buy a cheap tool, like, why did I buy this piece of garbage? It doesn't do what it's supposed to do. I need to invest in a better one. And I can't always afford the most expensive tools. So, for example, in this one here, this is about $3,000 new. I just did my due diligence on eBay and found out, a time when I actually have two of these, and one of them was from Martin Marietta, the rocket company, and they it said property of. So they apparently had a grant or something to update all the test equipment, and a whole bunch of these showed up on eBay. And I think I got this one for $500 compared to the $3,000 retail. And it's a generation older, but it's still a high quality tool. And I feel good about having one of the best tools, even though it's not as expensive as something that I could have bought. That would be a lower quality.
And with something like this, I mean, this may not be something that you're taking with you to every job. I mean, when you're doing just regular installations and regular integrations, something like that's going to do perfectly fine.
But a scope will show you things that these meters don't, and that the shape of that wave, that clipped deal there, you would never know that on here because it did not show you the shape of what it is.
That's true.
Right?
Yeah.
So if I have a clipped distortion coming out of a speaker, a scope can tell me, is that the waveform that's clipped, or has the speaker got mechanical problems, it does not. And I bought one of the very best scopes on the market here. It does not need to be this expensive. There are some entry-level scopes out these days that are a couple $100s or less that'll still give you the waveform and do a decent job if you shop around. It's just I'm a Fluke groupie here, so it's like the guys who buy Snap-on. I like the Fluke. That's their high end. But make sure when you invest in one that it's a difference between $80, $90 and a couple $100 will be more accurate all around, and get auto ranging, and a tool that may last you a lifetime as opposed to one that may not. So buy something decent is what I'm saying if you're going to invest in it as a tool. Don't get the $19 one, and that's good to throw in your toolbox at home for checking a bad fuse in your wall or something like that, but not for a professional situation.
Yeah, don't roll up to a customer's home with a Harbor Freight special.
Yeah, and not say everything Harbor Freight does is bad. I haven't looked at what they offer. They may have a higher end, $100 meter that's fine, but just don't buy the cheapest thing that you can find, thinking it's going to be as good because they're both meters.
Right. Okay.
So get that out of the way.
Get this over here. So when we look at we've learned so far that it's worth it to put the extra money and effort into getting one that's a better quality.
Sure.
We've learned that what the extra pin is on the bottom of it, or the extra port is, because I never actually knew that, because I've never needed to use that other portion to it to know what it is. So that's actually really helpful for me. But then of course now we've also learned that when you run into something specifically, so if you're looking at, and this still applies to the home theater side of things, guys, because what Joe just showed us here is that you can have a couple $100 meter that you are using to test the RCA outputs or the output of an amplifier because something weird is going on, and you're trying to find out what it is. You're trying to troubleshoot it. Well, that is going to show you that you may be at a high voltage, but it's not going to show you necessarily what that voltage looks like, and so you don't know if you're actually peaking on that system. And so if you actually, spend a little bit extra money, maybe get one for the shop for all of the guys to share, you can do something like this, which is going to show you, an actual image of what that signal is going to look like. That's very helpful.
And these will show you more than just voltage. They'll show you noise. They'll show you a lot of things as well. All right, so on the vein of different types of meters, here's one more.
Don't forget noise on the AC line, which we're constantly fighting, which you're not going to see on the $200 scope.
That's very true. Brent just walked in. He's watching from his laptop, but he was saying that if you notice also a dirty AC line, something that's like you showed us here, because when you plugged in and showed it on the meter.
Yeah, I was actually going to show that in a little bit of how you can see noise and things on a scope that you wouldn't necessarily read on a meter.
Right there.
That's
you
huge.
Should have at least one in the company.
Yeah, because at that point, that's going to tell you if you're fighting something like dirty power or bad power. That's going to tell you, yeah, it affects HDMI, HDBaseT, it affects all of that stuff. Infrared, yep, and for the extenders and whatnot, it affects everything. So that is actually really helpful for if you are, thanks, Joe. If you are at the point where you are, I'm not going to say fighting with the electrician, but if you're at the point where you're like, well, I've already replaced so much, of my equipment.
I think I used the little plug-in thing with the 3 lights on it to say yes or no.
But at that point, what that's going to allow you to do is be able to show, hey, this looks wrong. This doesn't look like it's supposed to look, and here's proof of that. That's really helpful in just that one application is worth it for me. I'll have to talk to a certain person about potentially picking up one of those.
Every company should have one in the company. Maybe not one on every truck.
Right. Yeah.
But certainly one in the company.
One in the company. Yeah.
Man, the
at
ability
least
to check power and look at. Because we fight those issues from tech support.
Yeah, all the time. Yeah. So, anyways,
these things get bounced around a little bit too, and all these tools, the Flukes are mine. These are from a bin at my shop, but I purchased my own test gear because one of the problems we run into in the shop is that not everybody understands the value and the importance of the tools being kept right, and one of the resistances of ownership is, hey, I bought one 2 years ago and it disappeared. It got left on a job site, or they ran over with a truck, and So I always like to have my own stuff to know that it's going to work right and do what I expect it to do, and I don't have to hunt for that one that's got torn cables or dead batteries or whatever it is.
That is very true. Yeah.
So if you're a professional installer, you should have
one for
the
yourself.
Tools that you need to do, and not be relying on the shop one to always do what it's supposed to do.
I'm going to take my my professional status off of my my position for installation, because I don't have one.
I don't either.
And you don't either. So Brent's going to have to take.
I've got the Fluke one.
Brent's been in the industry for longer than the Stone Age, and he doesn't have one. So we're going to.
I've got a Fluke. I've got both of the Flukes that he's got there. That's on my list.
Yeah, definitely.
So this one here is also a multimeter, but it's different in the fact that obviously the format's different here. It's got this little kind of an alligator clamp on it. And this one takes care of the problem that the standard multimeter has with the limits to the amount of current that it'll measure. So this is good up to only 10 amps. And using this to measure current of a device that's plugged into your wall, you got a problem with a circuit breaker blowing or something like that.
Right.
I'm a little hesitant to try to use this because I'm taking live power and exposing conductors and trying to touch this and touch this when it's 120 volts.
Yeah.
Shock hazard and sparks and fire and flame. So this is non-contact, and this one uses the property that I showed in one of our last trainings, that anytime we have power and we have magnetism that happens, the magnetism on this field, we had transformers here, right?
Yep.
The magnetism is proportional to the amount of current that's flowing through the wire. So this meter has a sensor, and it's a Hall effect sensor, that can detect the level of the magnetic field and read current without breaking the circuit. So that can be really useful to just clamp it around the power cord or something and see what the current is. So now I know if my breaker is big enough or how much wattage a device is pulling and all that kind of stuff.
So that's actually really cool. I have my meter is actually one like this.
Okay.
I've never actually used this portion to it other than to hang it on something while I'm using it, which I probably shouldn't do that. But so that actually allows you to read the current of something without needing to actually physically touch the item itself.
If you're going to purchase one of these, understand that just because it has a clamp doesn't mean it does everything you want it to do. There are still ranges involved of how high it can measure, but even more importantly, the vast majority of these clamp type meters only measure AC current, and they will not measure DC. It has to be an AC DC clamp meter to do that. So if you're trying to measure the power going to your starter in your car or how much your car amplifier is drawing, you're going to need a one that has the DC clamp, and not just DC down in here in the hardwire connections, but DC up in here. So I'm not sure there's enough current on this cord to actually measure it. It's pretty low.
Yeah, let's find out.
But we'll see if we can get anything on this here. So it's got a 0 on it, and all we got is plugged in is just a power supply right now. So it's so low, it's probably not going to do anything. But normally it would read there, and it's these are not going to read down into the tenths or hundredths of an amp very well. it would need to be something that would draw some serious power, you know, 5, 10, 15, 20 amps through there. But this one's good all the way to like 300 amps of current capability. So very good tool for that. And it can still do everything that a normal meter does, or at least much of what a normal meter does, because it has the ability to plug in down below. And I can still, you know, use my leads, and I still have the voltage settings that we just talked about. And this one is auto ranging. This one is, and most multimeters have the ability to measure AC or DC voltages. So depending on what I'm measuring, if I'm measuring something that's on a battery, like a car or even a tool, I would go to DC. If I'm measuring something that's musical related or coming from the wall power, music is AC and wall power is AC. I have to understand what I'm measuring to know, you know, what I'm going to happen there. So as Brent was talking earlier about noise, I haven't done this yet. So this is a cheap power supply that I purchased for a project I'm working on my shop, and it's a 12-volt power adapter. It's taking the 110 volts of the wall, and it's turning it into theoretically 12-volt DC. So I can go ahead and plug in my power supply here, and I can take my tool. Let's go to the regular Fluke here.
Now, you've got different leads for different options,
I'll get it
right?
to those in just a minute.
Yeah, okay. You've got plans.
Yeah. All right, so I'm going to go on to the DC power plug right here, and I'm going to touch the outside and the inside, and it's going to tell me that I've got 12.4 volts, which should be what would be expected here, and it is a DC voltage. Interesting to note that if I get these backwards,
it should still read it, but it comes up as a...
It's a negative now, yeah. Still
Right.
the same voltage, but the little minus symbol comes on. That's really important for knowing the polarity of this, which way is which. Because on my scope, I just built this little charging cord. I use this scope all around the shop, and it only had one charger for it. It turns out that I've got a bunch of Ryobi drills and a bunch of extra chargers that I don't need, so it happened to be that the Ryobi charger had the same voltage that the Fluke charger did. And I was like, well, let me just throw away one of those bases and I'll put an end on this and I'll use it for a scope charger. In order for that to work, though, I had to verify that the voltage was the same, even though it listed it on here. I wanted to make sure they're exactly the same. I didn't want to blow this thing up. So I used my multimeter to verify the voltage of the Fluke charger and the Ryobi charger, and they were within tenths of a volt of each other. That was fine. And I had to put a new end on. I had to solder this on here, right? I get a little DC power plug. And when you're dealing with one of these DC power plugs, almost without exception, the center of it is usually positive and the outside is usually negative. And I wired it up that way. And I was like, geez, you know, before I plug this in, I better be really sure because I don't want to blow something up in here. And I took my Fluke power supply and plug this back in here real quick. And I measured the Fluke. Okay. And it turned out that positive was on the outside and negative was on the inside. So it was backwards of what I expected. I would have wired in reverse polarity if I didn't use my multimeter to verify exactly what I had going on. Because normally the outside's negative and the center is positive, and that would have been out of polarity, would have blown up the charging circuit or the whole scope.
Yeah, that would have been catastrophic because
Yes.
it's DC power.
Yeah.
We would have completely fried out the unit.
Verifying polarity on DC voltages is extremely important, so we know that we got things right.
Huh. So Fluke, in all their infinite wisdom, which is probably to make sure that you buy their chargers,
Probably.
and to make you buy a new unit or something, but that's actually very, I mean, that's very true, because you need to be mindful of what you're plugging into it, because you could very easily burn up whatever it is you're using.
All right, so back to the original thing I was showing you, this cheap 12-volt power supply on DC volts. Go in the center here, and 12.5 volts, and it's in the right polarity. But another little thing you can do is switch to AC volts. Now, DC voltage shouldn't be giving me AC voltage. If I put this on here, I'm actually getting half a volt of AC voltage out of this.
Huh.
This would be noise on the charging cord. So whatever circuit I'm going to plug this into better be able to handle half a volt of noise of AC voltage on it and function correctly. There are some devices that can't. And that could have been the difference between the Fluke charger and this Ryobi one. One of the first things I checked is that it didn't show me any weird behavior there, and it actually didn't. It was fine. So this is a way to test how noisy this power supply is. This could also be used to check your car. If you go to the 12-volt battery of your car and set your meter to AC volts, you shouldn't see much, if any, AC voltage. 100 millivolts or so would be, normal. But alternators, when they go bad or when batteries go bad, they can have more AC voltage in the car, and that can cause engine noise in your car stereo. And this could also cause noise in, like we were saying earlier, HDMI cables or things like that. So that's something that we can actually see on the scope. If I can get it to connect. All right, so we're going to go to, should work like that. And get it to go in there. All right, so yeah, we can actually see that okay here. When
Switch right here.
I'm going to reverse the polarity because this is backwards. All right, so when you're at 0 volts down here, okay, this is, skip it all around here, so I'm going to short meter leads together. So right now 0 is right across here. It's staying steady and solid. There's a little bit of wiggles there and spikes. These are random interferences that are happening. But if I connect up the scope to my power supply again, it's going to jump up, and we can see all this wiggling. That wiggling is the noise. So right now my scope is on a 5-volt margin, or division. So where the A is 0, that's 5, that's 10, 12 volts. So I'm getting the 12 volts DC, that's this. But all this wiggle is the AC noise that's on that power supply. What I would like to see is a nice flat line across there and know that it's giving me a nice solid voltage. We can try a different power supply. So instead of this one, let's try that Ryobi one that I got going on. See how noisy it is. So that's going to be negative on the tip, positive on the shield. Much better.
Nice and clean.
Yeah. Huh. So that's what you get when you buy a $7 eBay 12-volt power adapter. So there's not much filtering going on in this. There's much better filtering going on that one. I don't have all that wiggling.
So this actually is showing us right away that there's, if you were using one of these power supplies, so let's say you were using just the cheap power supply on something like some kind of amplifier of some kind, all that extra noise is going to be translated into the system and into the audio.
Yeah. I've got a bunch of Dell laptops at the school, and we go through power supplies, they get tore up and stuff. So trying to save a few bucks, I went on eBay and bought some replacement Dell power supplies. And I got a lot of them, everybody's cost efficient trying to buy a cheap one. I got a bunch of them in, and they were charging, but suddenly I had mouse problems. The touch screen wouldn't work for the touchpad. And I'm like, oh, I must have a bad touchpad. And come to find out that the power supplies were so noisy, they were jamming the signal of the touchpad on the computer. So, that's something that you would never expect, right? You buy it and it should work, but it didn't. So that would have shown me on the scope the noise problem. And we saw a little bit of it here, with our meter. There was noise there, but now I can get a visual on it with the scope. That's kind of nice to see that.
Right. So we did that by, of course, flipping it over to the AC.
Yeah. So I'm measuring
instead.
a DC source. These are battery power kind of sources, right?
Yep.
But riding on that 12 volts is an AC component that is the noise. And,
that's really cool.
Both your regular meter set to AC measuring a DC voltage, or in this case the scope, will give you either a visual or a numerical readout of how much noise that is. And if we went back to the Fluke display, I could probably do the same thing. Got too much stuff going on here. So that one, we go back to our AC voltage on here. I would expect that this would have shown a lower noise than the other one did. Yeah, So the other one was half a volt of AC. This one's only got 20 millivolts of AC, 0.010 volts of noise on it. A much better power supply in that one. They have some sort of filtering going on in there. So, you know, either your standard meter will show you this or the scope.
Nice. So if you are limited with your resources and you only have enough to pick up, you know, something like the one that's a couple $100s,
sure,
versus the thousands of dollars one, that you can still get an idea of what's happening. You just may not be able to visually see what's going on.
Right.
So either way, pick up a good meter. If you can't go for the scope, you know, for whatever restrictions that you're dealing with, a good meter is still definitely worth it.
All right,
and
so
don't buy cheap, unregulated power supplies.
That's
yeah,
correct.
don't do. Yeah, go ahead and pick up a regulated power supply.
Yeah,
of some
I mean,
kind.
we would think 12 volts is 12 volts, but there's a perfect description. And now that I see this, the project I'm working, it may not even work properly. I've seen things lock up and latch and do all kinds of weird stuff when you give them dirty
We
power.
absolutely see it in IR.
This is something that,
Yeah.
well, this honestly is something that we are going to start using in our tech calls for different things that we are running into for surveillance. Quite a bit.
Yeah,
we
you
run
can
into
cheap power supplies,
or something else. Yes. Yeah, and you can run into an issue that locks up systems. I've definitely seen systems get locked up, and now I'm kind of curious to see if we're running into power supply issues. So stay tuned. If you're watching this and you've had issues with surveillance systems or any other device get locked up, give us a call on our tech support line. I'm kind of curious now. Of course, this is our tech support line here, 386-492-8584. I'm kind of curious to hear what you run into. I'm going to learn what Joe is teaching us today about how to use the volt ohm meters correctly and how to do certain things like this. And we're going to implement that. We're going to try that out and see what we run into.
Thank you again, Joe.
Yeah.
All right, so probably what's lacking in here is something like this. This is a toroidal inductor, and there's a bunch of copper and ferrite in here that, you know, would have added to the cost there. They probably left it out. But in that situation, if I had this device handy, I could probably insert that in series in here and filter some of that noise out. I could put the capacitor on it and make my own filters, but, you know, for the $10 extra, you know, it's probably not worth screwing with. So.
That is really cool though, because it's a nice little training of, you know, how this stuff works, because you can actually do it yourself.
Sure.
And build it yourself. So very cool.
You know, more basic things for the meter. You know, my tool's not working. Is this any good? Well, you know, here you go. Put it on your battery, and this 9-volt battery has 7.35 volts on it. That's a dud, right? That needs to go in the bin.
Yep.
It's no good. My remote control is not functioning. All right, well, pop that out. And, you know, it's important you understand what the voltage of these different types of batteries is. This is a little coin battery. These are usually around 3.2 volts or thereabouts. I can measure that. And, you know, that's partially dead. Probably still good enough to work. 3 volts on that. That's fine. A normal C cell, D cell, AA cell is about 1.5. And, you know, all that stuff is measurable very quickly to find out if something's working or not.
Now, everyone, this may seem like fairly basic stuff that we're learning about this, but these are things that, as an installer, this is an invaluable tool. This is something that you really need to have with you at all times. It should be in your bug bag, where, you know, your bug out bag, where you are going out to do some troubleshooting to find out what's going on. It should go with you to every single job. It should go in the house with you to every single job. Every time you get out of the truck to go and work on something, it should go with you, because it tells you so much good information. And this is something that a lot of times we're going to ask if you have one of these with you, and so that we can go ahead, or we may not ask you, we may just tell you, go grab your meter and test this. So make sure you have one with you, because that's a huge thing to know for sure of what's going on with this system, or going on with any system.
All right, so now we kind of quickly covered voltage. Another function the meter is going to have, and we call these multimeters. Adam called it a
volt ohm meter.
Volt meter. But really, that's an older version of a multimeter, because multimeters have many more functions than just volt and ohms, current and other kinds of tests as well. So multimeter means it does lots of stuff instead of just volt ohm. All right, so I got this little drill battery again. I can plug that up. I've just activated the coil of a relay, and I want to find out how much current this relay is drawing, how much it's you know, pulling, and this could be any kind of electrical device. So in order to do this, I'm going to set my meter up to measure current. So I'm going to move the lead over to the A, which is amps. And because I'm powering off a battery, I'm going to, and give me a little lead there to remind me to move my lead when I switched it. Didn't beep at me. But now I'm configured for DC, the straight line in the dot is DC, the curvy line is AC, so this is battery, it's DC. And I'm going to measure the current of this by breaking the circuit and installing my meter between the broken ends. The meter clicked, or the relay clicked. It's now powering the relay through the meter, and this is telling me that I have 0.136 amps of current flowing through this. So that's about normal for a relay. We normally about 150 milliamps. And 0.135 amps is the same thing as 135 milliamps, because decimal point 3 to the left is milli. So that's 1/10 of an amp, or 135 milliamps.
So what we're reading right here is the actual current that's being used by the relay to close.
Right, that's what it takes the coil to work. And if I had this relay doing a job, I could do the same thing on the power to the relay for whatever circuit I was powering in the car, for lights, or whatever you might be doing in a home with it, or things like that.
Okay.
So when it's disconnected, no current, and connected current. And just like on volts, if I do it backwards, that's not going to do it. I could do it down here. But if I get this backwards, it'll still show me the same current. The only difference is I'll get a minus instead of a plus.
So you actually get a negative current instead,
it's
because
flowing
it's reversed.
backwards. Yeah, polarity is just the direction of current flow, so it's flowing backwards through the meter instead of forwards, but that's current. And the main thing about current is that we have to remember to move the lead, and that it has to be in series. I had to break the circuit and put the meter in between the two ends. So originally I was on, got too many leads here. Originally these two were together, like so. That was my powered up system. To use an ammeter, got to break the circuit and restore it through the leads of my meter.
So we're actually running that current through the meter right now.
Yeah, it's got to pass through on its way. So it's a big circle having through. Yeah, and that's the only way current works, is by breaking the circuit and then reconnecting it through the meter. Right.
So that's also
AC,
why that's really special, that you have the other meter that has the clip on it, so that you don't have to put this in the line with everything else.
If I had something, again, this meter, the one with the current clamp, really does not work well for tenths or hundredths of amps. It needs to be up in the the tens of amps to get an accurate reading. But that's really when I need it, is that I'm measuring things higher than this can do. So that's our current measurements. The last common measurement on a meter is resistance. And resistance is going to be this ohm setting here. All right, and that symbol, looks like a little upside down horseshoe, is called the omega symbol, or the ohmic symbol. And this is used for measuring how resistive to flow a circuit or a component might be. So I got a couple of little demo guys here. I'm going to go back into where on the meter I measure resistance. Black always goes on common, by the way. All right, so I brought some little things that we can measure. This is a power resistor. It's a ceramic power resistor. It is telling me by the letters on it that it's 25W8R. So that's 25 watts of handling, 8 ohms of resistance. So if I measure this, it should read 8 ohms. But always important to realize is that meters don't always zero out. So right now the meter is connected to itself, and one would assume that this would be 0 ohms. But I'm actually reading 0.2. The lowest it can read is 0.2. It may have to do with resistance in the unit, calibration issues, resistance in my leads, but anything that has 0 ohms will measure 0.2. So something more than that will add to the 0.2. I have to subtract that 0.2 from whatever I get to make sure I'm getting an accurate reading. So when I connect up to my 8 ohms, if this is exactly 8, I would expect it to be 8.2. So it's actually not in spec. This is about an 8.6 ohm resistor, even though it's reading 8, because the 0.2 the meter already had, with 8.6 more makes 8.8. I subtract the 0.2 from the reading.
Okay.
You follow?
Yeah, so this one here, so that means then, of course, that this is either outside of spec or it's not what you want it to be, based on whatever their guidelines
and that's not
are.
Uncommon. Resistors are never 100% accurate. Resistors at different tolerances, you have to pay more for very accurate ones.
Sure.
And that's well within norm of what this is. Within 10% is considered normal.
Okay.
Getting back to that milli, kilo, mega thing.
Yeah.
3 resistors. I just made them common on one terminal. One of these is called a 2 ohm resistor. One is called a 2000 ohm resistor. And one of them is a 2 million ohm resistor.
Pardon me.
So 2 ohms, 2 k ohms, and 2 mega ohms is what I would expect here.
So you're connecting one to common, of course, and you're just going to check each one individually.
The first one, all right, 1.8 is my reading. So this 2 ohm resistor is actually about 1.6 ohms is what it's measuring out. And once again, the little hard to see, but the ohmic symbol in the meter is by itself. There's nothing along with it. If I jump over one more, 2.017 K ohms. The K means multiply that number times 1,000. So that's 2,017 ohms.
Yep. So
by
that's
our chart.
Yep.
The last one, which was rated to mega ohms, comes in at 1.971 or 70 big M ohms, 1.9 million ohms. So all of these were about 2 in the display, but boy, has that a lot of difference. 2 ohms, 2,000 ohms, or 2 million ohms. Got to look at the letter, and these auto-ranging ones that'll tell us. That's really important to look at.
Very important, because that's something that's the difference between something working and something not working.
Absolutely.
For one, but it's also damaging if you're using it incorrectly.
Sure. And you know, in cars all the time with my students, they'll come up to me and say, "Hey, this is not working. I measured, it's got 12 volts." And I'll walk up and look at the meter and I'll see 12 M volts. That's 12 thousandths of a volt. Well, you know, it's 12, but it's not the 12 you think it is. You got to make sure you look at that meter and understand what you're looking at.
Very cool.
This roll of wire here.
Just a spool of wire.
Yep. So, for purposes of demonstration, I unspooled this thing, and there's about 120 feet of 16 gauge wire here. And, you know, we always think that wire is a problem with our, you know, connections, and it's going to cause us a lot of issues. But how much issue does it really cause if we have a long run of wire? Well, we can find out the resistance of this run. So if I go from one end to the other, 120 feet of 16 gauge, and this would be a long run even in a house. It'd be longer than you would ever do in a car.
Yep.
But if I go through this, our reading is 0.9. So a single conductor of this is about 0.7 ohms. On an 8 ohm speaker, roughly 10% of added resistance. We lose about 10% of the power on a single conductor.
So just on that 100, how long you said?
120 foot
120
run.
feet run, you're losing about 10%.
Yeah.
Of your,
now actually you're losing more than that because you have 2 conductors.
True. Because
right? So you're going to the speaker and back.
Yep.
So if I, you know, tie those together and go all the way through both, the total resistance of the run is about 1.5 ohms. So, you know, close to 20% of the power of the speaker's lost, which might sound terrible, but you know, if you're running 100 watts to a speaker and you get 80 instead, it's probably not even audible. You know, that's maybe a 1 dB, a little bit more than 1 dB difference, and most people would never hear it. So, you know, can you use bigger speaker wire to eliminate this? Sure, but at what cost? You know, if I go to a 12 gauge or 10 gauge speaker wire, it'll get it down considerably, but I'm going to spend, you know, a lot more money on a long run like this.
So how much of a, now, of course, this is not in a straight path. We are in a coil.
Right.
Is
Coil
there an
doesn't matter
effect
for
of
this.
that? No, for what we're doing here.
Coils matter with, well, it
Technically,
does. Because it's a speaker, it's AC, right?
Right, yeah.
But because we're measuring resistance right now, this is a battery inside the meter is sending a DC voltage through the wire, and that's what we're measuring. So the coil of this has nothing to do with this measurement. In actual AC signals, yeah, I've created a big filter, and it would filter out some high frequencies and things, but you would never do that in a house because, you know, you don't run coils of wire in a house, you run straight runs. You know, that's a long run with a relatively small wire. It's not audible, so you don't have to go crazy and run really big speaker runs. When I was doing this, you know, professionally in home audio installation, I'd have customers all the time for their home theater surrounds that would want 10 gauge speaker wire run, you know, over a 20-foot run. It's like, you know, you're down into fractions of an ohm. It's never noticeable.
Barely, yeah.
But if they're willing to pay for it, of course, do it. But it's not a big deal unless you're running really, really long runs.
So we got a question. We got a question from Mammoth George. He's asking, is there a distinct advantage to the 200 megahertz on this, like the Fluke 199C, versus the 100 megahertz one? That's the 192.
It depends on what you're doing.
Okay.
Basically, that tells you how high a frequency the meter can resolve. So when you're talking 200 megahertz, you're well outside of the FM frequency range. When we're measuring audio, we're down in the 20K range, right? So thousands of hertz, not millions of hertz. So any scope will do audio waveforms and things like that. Until you get up into doing radio frequency stuff and worry about that, no. Now, This will show me some radio frequency stuff, interference on a wire that a cheaper scope might not, like all the way down. Some of these are only, you know, good for less than 1 meg in the really cheap scopes. But, you know, for clipping audio waveforms and things like that, it's fine for a smaller one. In some cases, I actually have to get into this one when I'm doing audio waveforms. There's a menu in here, and I have to get to it. I have to set the scope to high frequency reject, this setting right here. It actually ignores high frequencies because I can see high frequency noise from fluorescent lights and things like that when I'm trying to measure an audio wave. And you know, if I'm trying to set the amp gain, that stuff has nothing to do with anything. It's never going to come out of the speaker, but it messes with my curve and makes it look bad. So I'll actually set the scope to ignore that high frequency range because I don't want to see it. It's there, it's not going to affect what I'm doing, but I don't want it to mess up my curve and confuse what I'm looking at.
So when it's reading, so when this one says it's a 200 megahertz, that's basically the sample rate, that it's taking samples of whatever
Yes,
it's reading.
right.
So at a higher sample rate, it's able to get a more accurate reading of something that's at a higher frequency, so to speak.
It's able to display it.
Yes.
So, you know, if I'm trying to measure a 100,000 hertz wave and my meter's only sampling at 10,000 times a second, it's going to ignore all those things. It doesn't have the frequency response to measure it. This is essentially a frequency response setting.
So if we're doing something where we're just metering, say, amplifiers and audio equipment, then a 100 megahertz one would be perfectly fine.
And 100 megahertz would still show you radio frequency interference because that's all the way up into the FM band.
Right.
You know?
And so then, but if we're getting into something where we're needing to read like data transmission, which is at a much higher range, then that's going to be where something like this would come into play.
Yeah, and this won't even show, like, you know, for cable, you know, you got 2 gigabyte data.
True.
It's not going to show that, right?
Right.
So I'm sure there are spectrum analyzers, stuff that go higher than this for those kind of waveforms. But this is not what that's about. It's just, you know, for seeing the waveforms of things that are more normal that we deal with on a daily basis.
That's also why we don't use something like this to measure HDMI, because HDMI is much higher.
Yeah.
We're talking into the, like, I think right now for HDMI 2.1 we're in 12 gigabits.
Yeah.
Well, it's gigabits, but we're in such a much higher frequency for something like that.
And I'm sure there are scopes that go higher than this one, but, you know, if this is $3,000, then, you know, what's a scope that's going to do more than that?
Right. Yeah, we're getting into tens of thousands of dollars.
And that's why your HDMI cable testers we're talking about are $15,000, you know, because of the
Yep.
You know,
yeah, exactly.
So anyway, for resistance, you know, the meter is useful to get us our runs and make sure there's no breaks and things like that. What it's not useful for is measuring extremely low resistances. So that 120 foot barely showed on the meter. Here's that inductor call I had out earlier. You know, I want to make sure that this doesn't affect my current flow in my circuit, so I'm going to check how much resistance it has. And 0.2. 0.2 is the same
as if you shorted
I shorted out. I know this has resistance because everything has resistance, but it's so low that the meter can't resolve it. So this particular meter and most meters won't give us extremely low resistance values. All the time in car, guys say, well, I used my meter to verify my ground was good. Nope. You know, a ground of a couple hundredths of an ohm is a poor ground. This isn't even close to displaying that. This is displaying tenths. So you can't see if your ground's good or not. You can see if it's connected to metal, but you can't tell if it's anything, you know, if it's going to work properly. With this type of meter. There are micro ohm meters that will do that, but not in a typical ohm meter.
So this actually feeds into, and I'm sorry to keep derailing it, but I'm applying this now to what we've dealt with. So one of the things that we deal with when it comes to especially HDMI extenders is the termination itself. And the termination itself, if it's not a good seated termination with like an Ethernet connection or an RJ45, it may work initially, but over time it begins to fail. And so with something like that, the way that you described the grounding issue, to where it may not be, you know, when you put the meter to it and you check the continuity on it, sure, you get okay grounding, but it's not enough for it to actually pick up on how much of a difference there is.
Yeah.
And
so I don't know what level of, you know, of poor connection is enough to throw it off. If it's hundredths or tenths of an ohm, it may not resolve in a meter, but if it's tens of ohms, then it would. So it depends on how little it takes to throw it off.
Would probably be, I believe it's in the hundreds. I'll have to double check with some of the guys that actually mess with that part of it, but yeah, the tolerances are very, very low.
All right, so a couple other things about reading connections with resistance or reading ohms. The meter, while it cannot read very, very low, it can read very, very high. So if I just touch these leads, I'm reading me. Right? So I am 1.9 mega ohms of resistance right now. And I like to show my students, I'm a little bit of a kind of a guru here. I can actually change my resistance. I'm going to make it go down here. And I'm going to make it go back up. And I can do that with my thought. If I think of something creepy or you know, hair-raising, my skin resistance changes. And that's the same for any human. It's the root of the lie detector. They actually put the little clamps in your fingers, and when you get scared or think you're lying, your skin resistance changes, and that's something they see on the screen. So you have a basic little lie detector here that you can play with. But the fact that we have resistance means that you have to be careful when you're taking measurements with a tool like this, because if I go back to my mega ohm resistor, okay, and it's 1.9 mega ohms, if I'm touching this while I'm measuring,
you're going to throw it way off.
Yeah, it's now telling me it's 500 kilo ohms versus 1.9 mega ohms. I cannot touch the leads because I become an extra pathway for the voltage that's in the meter to calculate. So high resistance, I need to leave it alone and not touch it. If I'm measuring a low resistance, I'm so high that it's not going to affect it at all.
Because it doesn't care about you.
Yeah,
the electricity wants to pass
millions
through.
And it's 2, so
Right.
you know, I'm so far beyond what it is, it's not going to matter. But
Right.
some resistance measurements you might throw off by touching the leads, or at least both leads at the same time. So be aware of that when you're measuring very high resistances you can't touch. Another thing you have to be careful of is when you measure things that are like speakers. So I've got a little mid-range driver here. This is 3.7 ohms. That's going to be a 4 ohm driver. But if this cone is moving whatsoever, that reading becomes very unstable. That could also be by me talking to it loudly, maybe. Right? And if I'm in a noisy room with this speaker in a box especially, the cone is going to vibrate to the noise in the room. It's going to throw off that reading. The reason why is when a speaker cone is moving, it's a coil moving through a magnetic field. That's a generator.
Mm-hmm.
If there is voltage on a circuit that you're measuring while you're trying to do resistance, the voltage that's in the circuit interacts with the voltage that the meter is pushing through the circuit to measure it, and it's either going to add or subtract your voltage or your resistance measurement. So you cannot measure live circuits with resistance. It has to be unplugged and powered down to get an accurate reading.
That's really cool. Joe, we're at an hour and 13 minutes.
Okay.
And I've completely forgot to check the clock and find out where we were on that because I've been learning so much today.
Well, I've got more, but we can do that another day.
That would be great. And are there any final thoughts that you want to leave with the viewers on anything else to take away from at least this episode?
Yeah. Make sure you have a meter. Get the best one you can and play with it.
Yeah.
Use it on a daily. Get used to its functions and its features and how it works. And when you understand what they can measure, it can get you out of a lot of tough spots when you're dealing with problems.
Yep.
And that's really what it's for. It's troubleshooting. When things aren't going right, this can help you out to find out what it is.
Yeah. So that's kind of the main point of today's episode is really just to talk about the fact that you need a multimeter of some kind. You need to have a tool like this so that you can stay, it's not even really just staying up to date with everything because this has been around for so long. It's really because this is one of those items that's just a mark of a professional. To have a multimeter with you on every job, it makes you look like a professional. And when you do have a problem that you need a multimeter on, or you need to check something, or something is just acting funny, this is an amazing tool to have for those applications. I think that this is a fantastic episode to continue on. I almost want to make this kind of a regular thing to talk about how to use a multimeter or how to use certain tools like this.
And we touched on the scope, but there's a lot more to the scope too.
Yeah.
So that's if people are interested in that, we can do that. But There's some other functions on the meters that are useful that we haven't gotten to.
Yeah.
We can do that another time.
This is great. Tony, it's great to see you in the chat. And Mammoth George, thank you for your question. If anyone else has questions about anything that we've talked about today, or if it has anything to do with you have a question for Joe that he might be able to answer from Installer Institute, please feel free to leave it down in the comment section below. Or, of course, you can email me. Whoops. Hit the right button there. You can email me at adam.rogers@metraav.com, and I can forward those questions over to Joe. You can, of course, give us a call here on our tech support line, 386-492-8584. We're happy to talk about whatever we have going on. And if you have questions about anything we've talked about today, again, please leave it down in the comment section below. Fatoni is saying back in the 90s he sold so many of the multimeters in his Radio Shack when he was running one of those. So that's really cool. So everyone, thank you so much for checking in today. This has been just an eye-opening day. I've learned a lot myself. I've known how to use a multimeter, especially when it comes to continuity and to read voltages. At least I thought I did. And I've actually learned quite a bit about what happens when something is clipping. There's been multiple times that I've taken a meter and just touched it to an RCA connection to see what happens, because I was curious to see what would show on there. And now looking at what you've shown us today, I think I have a better understanding of what it is that I'm looking at in that aspect. So. Sure. Because I think for the most part I was doing like a DC connection to it or DC reading instead of an AC one. But so very cool. So everybody. As always, thank you for watching. Like, share, subscribe, hit the little bell notification to let you know whenever we do go live, which of course is every Wednesday at 3 p.m. Today is the day before Thanksgiving, so everyone here in the United States, thank you so much and have a happy Thanksgiving tomorrow. We will not be here Friday, so we have no Friday episode for us. However, we will be back next week where we will be talking about the importance of terminations whenever we deal with a system. So, Joe, again, thank you so much for joining us today. As always, check out installerinstitute.edu is the website. So installerinstitute.edu for more information about that. I believe, are you all starting? Are you in the middle of a
we have courses starting at multiple start points all through the year, so we've got a class just starting, we've got a class just ending. So
perfect. So it's a good time for that. So got Jason here as well, and he's off camera, so I remembered your name today. Who are you? So everybody, thank you so much as always for checking in with us. We'll see you next time. Come back next week where we'll talk about the importance of terminations. And if you like Joe being here on the videos with us, let us know in the chat or down in the comments so that we can start bringing him in more often. We can start trying to incorporate more of Installer Institute. So everybody, thank you so much for joining us today. We will see you all in the next one. Bye now.